Okay, so I think we can give a little bit some extra time to the people who are joining. Meanwhile, I will start to introduce you a little this clustering initiative of the sister projects. So it's Alpha Wetlands, Restore for Seas, REWET, and Wet Horizons, with also the presence of the Society of Wetland Scientists today, the European chapter. So welcome everyone to the first session of our webinar, Wetlands in Action. So the first session will be dealing with tracking carbon and greenhouse gases emissions dynamics in wetlands restoration. We will have three main speakers in the panel for today. So it's going to be Miguel Cabrera-Brufau from Restore for Seas, Liang Chen from REWET, and Columba Martinez from the Society of Wetland Scientists European chapter. So once again, this webinar is a clustering activity under the definition and communication of the sister projects. It's really meant as an activity actually to get together all the, let's say, the interested parties and the researchers that, of course, are dealing with the wetlands restoration. As you know, all the sister projects are actually part of the same call. So this is a little welcome to, of course, let's say, introduce you to this initiative. Lena, please, next slide. So before we go into the, let's say, the live session with our speakers, very briefly, some basic webinar rules. So as you know, we have launched the registration right now. So like this session is going to be recorded and be available for the audience afterwards. So please keep your microphones muted unless you're invited to speak. Use the chat box to post your questions and comments. I anticipate that at the end of each speaker's presentation, there will be 5 minutes allocated to the Q&A. Please, the questions will be accepted and posted actually in the chat. So we will tend not to open the microphones for the, let's say, the participants to the audience, but we will kindly ask you to submit your questions in the chat. Of course, screen sharing will be restricted only to presenter and host. And if you have any technical issues, please try to contact the audience, the host, sorry, privately. Lena, next slide, please. So very briefly, as anticipated, so this webinar is actually part of a furthering clustering activity for the sister projects. One other, let's say, activity that we led is the creation of this hub, which is a joint effort of the sister projects. It's actually a LinkedIn group that is meant to actually host wetland restoration exchanges. You will have automatic joining. The four sister projects communication dissemination leaders are the admins for this group, including myself, my colleague Irina, who's here, Corina for Wet Horizons as well, and Maria for REWET. In case you cannot join directly the group, please do not hesitate to add us on LinkedIn, and we will be more than happy to add you to the, of course, to the group. Next slide, please, Lena. Very briefly, a little bit of introduction about the agenda for today. So we're gonna have the first introduction is gonna be made by me, of course, it's taking place now. Then it will be followed by the presentation and Q&A for Miguel from Restore for Seas. Same thing for Liang from REWET. And then we're going to also have a presentation from Columba Martinez from the European chapter of the Society of Wetland Scientists. Then it will be followed, of course, by next session announcement and final questionnaire feedback. Perfect. I think that we're now good to go. I will give the floor to my colleague Miguel Please, Miguel, you can open your mic and your camera, and we will be happy to listen to your presentation.
Thank you, Madeira, and thank you everyone for joining in. So I'm Miguel Cabrera from the University of Barcelona, and today I will try to give you some insight into whether coastal wetland restoration reduce greenhouse gas emissions. And I will do that with two examples from the project that I'm working in. Next, yes. Yes, so coastal wetlands provide multiple ecosystem services. They exert a disproportionate role in greenhouse gas regulation. However, in Europe, they have suffered historical losses and degradation that the European restoration law, among other efforts, is trying to revert. Next slide. However, these increased restoration efforts have to be guided by a better understanding of these systems. These systems, at the moment, the high complexity and competing interest in terms of the goal of restoration, joined with a lack of knowledge, it's making us very difficult to predict how greenhouse gases fluxes will respond to wetland restoration. Next slide. So overall and very simply, the wetland carbon biochemistry is mostly driven by two competing processes or two directions. We have predominantly CO2 uptake by photosynthesis, and the emissions are driven by mostly respiration in terms of CO2 and emissions through methanogenesis in terms of methane. Next slide. So yeah, as I mentioned in the title, here I will try to answer the question of how effective is wetland restoration from greenhouse gas, specifically CO2 and methane mitigation. First, if greenhouse gas fluxes are related to the ecological status of the system, and then more in detail, what is the change in greenhouse gas fluxes after restoration? Next. And to do so, I will be answering these questions in two of the 6 wetlands that compose the Restore for Seas project. The Ria de Aveiro, which suffers habitat loss, and the Curonia Lagoon, which suffers mostly from water quality issues. Next. So our sampling design within the Restore for Seas project, we have 6 different wetlands, of which I will talk about 2. And in each wetland, we have 6 different sites, 2 preserved, 2 altered sites, and 2 sites where restoration has occurred. And we have sampled each of these sites during 4 seasons. Next slide. But how do we measure greenhouse gases within a wetland? So in the Restore for Seas project, we have used static chambers that are distributed across the wetland space proportionally to different strata. So bare sediments, vegetated areas, and open water areas. And we use 2 types of static chambers. Next slide. So to estimate or to measure the daytime fluxes, we use transparent chambers with which we can isolate a tiny bit of the atmosphere of the system and relate changes in greenhouse gas concentration inside the chamber to the surface fluxes. Next slide. For nighttime fluxes, we do the same, but instead of measuring at night, we just use a dark chamber as a surrogate for nighttime conditions. Next slide. So with these 2 approaches, we have instantaneous fluxes for light and dark conditions. The next step for us is to estimate a daily exchange in which we scale these light and dark fluxes to the lighttime and nighttime hours of each site. And then finally, we calculate the global warming potential using the 5th assessment of the IPCC for 100 years of warming potential for methane. And the total warming potential is the sum of CO2 and methane. Yeah, next slide. So the statistical approach, very simply, we try to relate the daily change in greenhouse gas flux to the status of the system, the ecological status of the system, the season, and the presence of vegetation. The important thing is that this process allows us to isolate the effect of the ecological status and to compare between the three different status. Next slide. Yeah, so as I said, first, we are going to look at the Ria de Aveiro case. In this system, these are seagrass beds, seagrass meadows of Toster and Nolte, and the main alteration is the loss of vegetation due to stumping and bait digging. The restoration that was carried out was to actively transplant patches of seagrass. Next slide. Okay, so here we have the results of the Ria de Aveiro. There's a lot of information, but just for you to, I will get you through it. So first, in the left panel, we have the CO2 daily exchange, and we have that for the preserved, altered, and restored condition. And the letters on top indicate significantly different average. So for the CO2, we can see that the sites where we have seagrass have a stronger uptake than the ones that are altered. For methane, on the other hand, we see that we have higher average fluxes for preserved and restored conditions with respect to the altered ones. And this likely has to do with higher organic matter in the sediment, promoting the emission of methane, although this emission is very little. And when we look at the combined global warming potential, we see that these opposing patterns in CO2 and methane emissions or methane or fluxes are mostly dominated by the CO2 reduction. So we can say that the restoration of the Ria de Aveiro site effectively regained the biogeochemical functioning of the system and had an overall cooling effect. Next slide. Next, we have the Curonian Lagoon. This is the largest freshwater lagoon coastal lagoon in Europe. And the main alteration is to do with eutrophication, so high nutrient loads in the water. Correspondingly, the restoration that was carried out was related to water treatment and removal of contaminated sediments. Next. So here we have exactly the same slide as for the Ria de Aveiro. And if we start looking at the CO2, we see that the alteration, in this case, lowered the CO2 fluxes. And this is likely related to higher uptake or higher photosynthetic activity of cyanobacterial blooms within the water column, taking advantage of this enhanced or this elevated nutrient load. However, when this phytoplankton dies, they sink to the bottom and they accumulate as organic matter. And if we look at the methane fluxes, we can see that this organic matter accumulation led to a very large increase in methane emissions. These opposing patterns for the CO2 and methane, we saw that in this case, the methane emissions were the overall dominant. Next. So with this, I've shown you two examples. However, across all of the case pilot wetlands, we typically saw wetland-specific responses to restoration of CO2 and methane, often with opposite direction. However, it's important to know that in any case, we never detected an increase in the global warming potential. It either decreased or remained the same after restoration. Next. So to finalize, here we have seen that there is high within and intersystem variability in greenhouse fluxes. We've seen that greenhouse gases have specific responses to restoration. Seasonality and vegetation always was important and modulated the response to restoration. And restoration, even though it wasn't intended for this purpose, for greenhouse gas mitigation, in any case, never produced an increase in the global warming potential. So the first thing is to do no harm. And we have seen clear restoration successes in the two examples that we have that I have shared with you today. So overall, coastal wetland restoration shows potential for climate mitigation, but it's important that we tailor the restoration strategies to the type of alteration and the type of wetland in each case. And that's all from my side. Thank you very much. I'll be happy to answer questions.
Thank you, Miguel. Yes, like once again, because I've seen quite a lot of people joining a little bit later. So to clarify, please, in case you have questions or need for clarification, or you want to address Miguel in any way, please post your comments or questions to the chat. And now we are opening the floor for the questions. So please like take advantage of this moment to dig a little bit deeper into Miguel and Resurface's research. I've seen that there are like in the webinar quite some people from also sister projects and some participants that have been present at the Resurface's autumn school that we held in Malaga. I think it was a couple of weeks ago. So very happy to see you back in this webinar. Do not hesitate to like interact with Miguel and to ask some questions. It has been a very extensive work for Miguel and for the colleagues. As you can see also in the nice pictures, they've been actually sampling for a whole year in all weather conditions and so on. You know this job very, very well. So please do not hesitate to reach out and ask him questions. And once again, also maybe can be like a space for the sister projects to further clarify some points, or maybe to exchange, considering also that they have some other case pilots. And if you want maybe to take advantage of this moment, go ahead and yes, I see Vanessa is actually interested and wants to raise a hand. Vanessa, if you cannot post the question in the chat, I will kindly ask my colleague Irina to open the microphone for you.
Oh, sorry. May I ask the question or just include it in the chat?
Please go ahead. It's fine. Now it's open. So go ahead.
Okay. Thank you very much for this presentation, Miguel. Very interesting. I'm Vanessa Sanchez and I work in Fundación Global Nature. So we were involved in the Live Wetlands for Climate, and we were working on this same methodology together with the University of Valencia with the team of Antonio Camacho. I think they are partners of you too. Yeah. So I have a question that I should already know, but I would like to know your opinion about that. Is well, I understand that your methodology doesn't include nitrous dioxide.
No.
Yeah. And yes, I would like to know if you could explain your reasons to exclude this such a high global warming potential gas, and I think it's not an easy question, but just to know about it. Thank you.
Yeah. So thank you, Vanessa. As she has mentioned, I've left out of my presentation a very important greenhouse gas, especially in wetland system, which is nitrous oxide. And it was not that we excluded it. It was that we didn't have the technical capacity to measure nitrous oxide in a similar way to CO2 and methane. We did take samples from the sites, and we have estimated the fluxes with a different methodology. So doing incubation of sediment cores, but unfortunately I didn't have time to include it here. And I would say that this is a very general constraint in greenhouse gases research in general. We typically tend to focus mostly in CO2 and methane. I think it's mostly due to just the easier measuring of it and the higher availability of instruments that can measure these fluxes. But yes, for sure, a global warming potential estimation or the assessment of climate mitigation cannot be complete without including the nitrous oxide fluxes.
Thank you, Miguel.
Thank you.
And thank you, Vanessa, for raising the question. Miguel, very briefly, we have another question in the chat. I will read it for you, or you can go through it, but I will read for the audience. So, hello, Miguel. I wanted to ask, in the second example, the uptake of CO2 was more in the altered case, or the demo, the graphic referred to the CO2 emissions. I hope the question is clear. I think I missed an information.
Yeah, I went very quickly over everything. So every graphic and every plot that I showed always referred to the daily balance of fluxes, being positive fluxes towards the atmosphere and negative fluxes towards the out of the atmosphere. So yes, in the second case, the Curonian Lagoon, the alteration caused an enhanced uptake of CO2. However, the uptake of CO2 was mostly in open water areas due to phytoplankton, which produces very labile organic matter. So this instantaneous flux, let's say, was not well or didn't translate into long-term carbon storage. And not only that, but the emissions associated with this organic matter degradation were in form of methane, which is much more potent as a greenhouse gas.
Perfect. Thank you a lot, Miguel, and thank you for the audience to raise the questions. It is now time to move to Liang Chen's presentation. So Liang, the floor is yours. Liang is from the project REWET, I forgot to mention. Thank you.
Thank you. Hello, everyone. My name is Liang, and I'm from University of Eastern Finland as the Open Lab for the REWET project. Today, I'm going to talking about the greenhouse gases in our site named Ylpässuo. Next one. Thank you. As we know that the peatland is a very unique landscape. It stored a lot of carbon by the unique growth. Next one. Because the new biomass usually grows on the top of the older biomass. So you can see a very clear layer by layer. And in this way, the peatland ecosystem stored a lot of carbon. And it's very important that for the mitigating the warming climate if we protect them properly. Next one. But now I discuss something about the Finland situation. The Finland is famous for their forest coverage and also the peatland. Finland has approximately 9 million of this peatland, and but unfortunately, 53% of the peatland has been drained. That means totally disturbed because they used to convert the land into other land type use, for example, the forestry and agriculture. And the rest of the undrained peatland also affected by the surrounding land use, even they are not touched, but because of the hydrology connection. So when the surrounding land tap the water level down, so the more or less will affect the undrained peatland as well. Next one. And as I mentioned, the peatland is widely converted to other use, for example, forest, agriculture, and the source of fuel. And as the figure here, we can see from north to south, the most all the peatland has been drained and converted to other use. So so that's why we need to think about it. Next one. So the drainage of the peatland brings a lot of consequences. For example, the loss of biodiversity and more greenhouse gases, for example, CO2 and the methane flux. But in other words, the stored biomass will be released into greenhouse gases by the human disturbance in advance. And rewetting is considered a good way and economic way to protect this or restore this peatland. And in this REWET project as an open lab, we use this eddy currents system to monitoring the greenhouse gases in a very fine time resolution at ecosystem scale. Okay, next one. So the our site actually is funded in 2020 and donated by University of Eastern Finland, and because the site is a bit north of the Finland, so we have almost half year covered by snow in the site. The mean peat of the mean depth of the peat layer is around 1.7 meters. Okay, next one. And the eddy current system is set up in 2023. We have a different gas analyzer for different gas flux, for example, CO2, water, and the methane flux. And we also have this phenology camera to detect the plant stadium and growth in this peatland ecosystem. Okay, next one. So here is an example about the phenology camera. So with the camera, every day we take a picture with a fixed angle, and we then select the interested area, region of interest, mainly about the peatland species, and then we can extract the RGB color channel to calculate the phenology index to be as a proxy of the plant growth. Okay, next one. And with the eddy current system, we also applied the pipeline, data processing pipeline. We use a different software algorithm and a lot of filter methods to get the final results. Okay, next one. And for the results, and first we are more interested about whether the carbon flux is mainly from peatland rather than the surrounding forest. That's why we have to check the footprint. In case in the calculation we involved some flux, they are actually from forest, not the peatland. So here is the footprint from the growing season in 2024, and we can see that all the flux actually contributed by the peatland itself. So the forest have zero impact to the carbon flux. Also, the right corner of the scatter plot shows that the energy closure in our site is very good. That means that the data quality shows quite stable and reliable. Okay, next one. So one big problem with eddy system is you always have a lot of missing data, and because of a different reason. Because in our site the power supply is from a solar panel. So in winter there's no electricity. So in winter you can see a lot of black observations. That means missing value. So we use some algorithm to gap fill the missing data from the daily data set, we can see that in Ylpässuo, during growing season, it's mainly acting as a carbon sink. That means they absorb a lot of carbon CO2 from atmosphere, and also it's as a methane source. That means when the growing season start, the peatland start to emission the methane and reach the peak during the summertime. Okay, next one. And we also check the some correlation of the greenhouse gases to some environmental factors, and we see that the net greenhouse gas CO2 ecosystem flux is more related to the temperature. However, the methane flux is more related to the humidity of the air and also the VPD. But we actually have some water level data, but I didn't involve in because during that time the water level data is still under processing. Maybe in the future I will involved in the water level data. Okay, next one. And this is the phenology observation. And after we use some image processing technique, and we extract the area and calculate the phenology index, and we can see that the phenology camera can detect the peatland growth quite well. Okay, next one. And for the restoration project, we always wondering how we compare before and after restoration. That's why we think about maybe we should use some satellite image to connect the peatland before and after restoration. So we use the Google Earth Engine and extract the modest productivity data. Okay, next one. And thank you. And we got the GPP, MPP, and EVI, the vegetation index, and the results didn't show much significant tendency here. That means probably the peatland restoration is a long-term process, which in a short period we cannot directly detect the changes for the aspect of the plant stadio. Okay, next one. So overall, so in our side, Ylpässuo is a carbon sink, but still is a CH4 source, and the greenhouse gas emission need a long-term monitoring, especially how we compared before and after restoration. And additionally, we further needed to plan to combination of different technologies together to break down the flux to species, plant species, and water table and other characteristics. Thank you. I think that's all. Yeah, thank you.
Perfect. Thank you very much, Liang, for your presentation. I think now it's time to open the Q&A. So please, everyone, do not hesitate to address your questions or comments to Liang. This is the moment, let's say, to raise this kind of questions and to fuel the conversation. So once again, I will stress out that you are encouraged to post your questions in the chat. I will read them out loud and so bring them to the attention of Liang. Otherwise, you can open your microphone and directly speak to Liang. So we have a few minutes to have this conversation. I'll leave the floor to Ricardo. Go ahead.
Hi, Liang. I just have a quick question regarding the methane emissions. From what I understand, that you don't have like before the restoration any measurements. So have you compared these emissions to other peatland restoration projects in Finland, or are they high compared to other sites, or low, or kind of in the same like range? Thank you.
Thank you for your question. Yes, it's a bit challenging to compare the missing fracs from before and after restoration, but we have some sibling sites. As we know, we also have this missing sensor there, but we honestly at this moment we didn't compare the magnitude or the amount. I mean, the amount of the missing fracs, and so we plan to do that honestly, but we didn't directly compare.
Thank you.
Yeah.
Thank you, Ricardo, for the question. We have, I think, a few extra minutes for a second question in case you want to reach out to Liang. It's the moment. Agatha, please go ahead.
Thanks for a very nice presentation. I have a question about maybe I missed it. How long ago was the site restored, and how degraded it was before it was restored? So, from my experience, if you have the sites in some parts in Finland, you know, they are definitely they were drained at some point, but the drainage was not maintained well. So actually, the degradation is not so far or not so heavy. And then after restoration, they can come back to sort of close to natural situation quite quickly. That's why my question.
Yes, I think the main issue there is that before 2020, there are a lot of logging practice around the peatland. That means the cut the tree is clear cut. That means remove all the tree and planting new trees there. And this is one thing. Second is a lot of ditches are digging there, so the water table going down quite many. And since 2020, so all the logging and the drain has been stopped, and especially the ditches has been blocked, so they fill with some soil and things to block and fill the ditches to maintain the water level there. But as I mentioned, from the satellite data set, we didn't detect significant changes of the GPP or vegetation index. Probably, I don't know, maybe we need more time to check the changes, maybe. Yeah.
Perfect. Thank you very much, Agatha, for the question, Liang, for answering.
Thank you.
I'm afraid we are out of time for the Q&A, so I will kindly ask you, Lena, to move to the next slide and introduce you to Columba Martinez from the Society of Wetland Scientists, European chapter. So Columba, the floor is yours. Thank you.
Thank you, Maria. Well, nice to see you all. I think if there's already people from the autumn school, you already know me, and you will already see that this presentation is similar at what I present in that autumn school. And I'm really happy to share the floor with people that work with greenhouse gases, because I'm a researcher but focused on nitrogen fluxes. So I'm really happy to hear these discussions. But I'm here just to promote the Society of Wetland Scientists. I'm currently the president of the European chapter. I start the mandate this year. And I would like to talk a little bit more about this society. Please, next slide. So it was founded in the 80s in the US, and it now has 3,000 members in more than 60 countries. And the idea is to ensure that wetlands are understood. So, well, I put it exactly how it's written in the site, in the society, because I find it important to to really convey what is the objective of the society, their importance recognized, and that sound wetland science guides both professional and the general public in the research, conservation, preservation, restoration, and management of wetlands in a changing environment. So this is a global network with different chapters and sections. The sections are related to topics, and the idea is to federate as much as possible the wetland scientists that sometimes we are all over, but because it's difficult to exchange, because there's some projects, and I think what is interesting of this network is that it stays in time, no? So you can always refer to this society to find some expertise. Next slide, please. So more in local terms, what the chapter wants to do is that we want to focus on the European wetlands, because we have this international network. So our idea was to become strong as a European network. So then be able to exchange with the same knowledge as other chapters that are way more developed, and they are formed before us, no? Because the European chapter was formed in 2004, so it's a little bit later of the original creation of the association. So, well, these are some points that they are already part of the main society, but we want to focus on the European, no? So promote, foster conservation, advance public education, provide independent forum, support the students, encourage the advancement of wetland scientists and practice, and promote knowledgeable management, and establish partnership with other wetlands organizations for international collaborations. So, well, this is the idea, and what you can see is that all these points are not only focused on scientists, but also students and practitioners. So we want to be able to link all the people that works in wetlands to talk to each other and try to transfer the knowledge. Next slide, please. So just to tell you a little bit of how was this 2025, no? We are almost at the end, so I can tell you some of the events, actions that happened this year. So there was the annual meeting where I have the pleasure of meeting some of the people of the Restore for Seas, Alpha Wetlands, and the other sister projects, and also exchange and see how like they are really active, and there are many projects working in wetlands, but unfortunately not all of them know about SWS, no? So then it was a good space to say we need to really try to do something for make this network stronger, and I'm happy to be in this seminar. Then the SWS is also part of, as a technical and scientific support of the Mediterranean Alliance for Wetlands, that also some of the collaborators of these projects are part of it. And we collaborate with IUCN. No? So the beginning of the objectives that I presented, they are actually ongoing. No? And we can say that 2025, it's one of the years where we tick all the objectives that we decide we're gonna promote. There was also an online symposium for early career and students at the beginning of the year, that it's at the same time as the Wetland Day. So we do this early career to really focus on students, so then they have space to present their research, and we give them a grant that sometimes is a travel grant to present in the annual meeting. No? So then there's the possibility to start online and then meet in person. Next slide, please. So that's Europe, and then if we zoom out again, for the Society of Wetland Scientists Network. There are many resources online that you have access, even if you are not a member. There are some, there's the international conference that normally happens in the US or around the world. This year was in Rhode Island. Next year, I think it will be in Louisiana. And there are some webinars that are happening, organized by the headquarters, and that you can find some online for free and access to everybody. And I put just this screenshot of the website that it was just recently renewed, and that you have some latest news, calendar, and resources that are available even if you are not a member. Next slide, please. And I also wanted to invite you to present your research in the next annual meeting of SWS that will take place in the University of South Bohemia in Czech Republic. If you're a member of SWS, you will have a preferential rate fee, and the invitation will come soon. So this is a space that this year we are not partnership with other big conference, so it's expected to be like a smaller conference than Intercol, but still really focus on wetlands. Next slide, please. And finally, another benefits of SWS network and Europe is that you can have online access to the Wetland Journal, the Wetland Science and Practices that are journal of the society. So it's really a society that has many researchers that are involved in science, no? Like a real long-term people that lifetime that really you read all the time, you cite all the time, they are part of this society. I don't want to cite anybody because I'm afraid to left out people, and I don't want to to make any compromise, but you can check it out. Then there's also the practitioner wetland certification that is useful for practitioners. No? If you are not in science and you want to put in your CV that you are certified as as an expert in wetland scientist, the society can provide this certification. There are also opportunities related to different posts around the world that other partners ourselves are able to post. And the other mechanism that is like a recognition of wetlands, so Ramsar sites or things like that, is the wetlands of distinction, that unfortunately we don't have many of these level wetlands in Europe, but I think there are many that could be labeled as wetland of distinction. No? It's a little bit of work to do all the administration, but it's something that could be interesting to also work on it, to have some recognitions. There's online forum and wetland interviews. No? Sometimes they organize like a seminar or they interview experts. So it's another way of knowing researchers and their work. Next slide, please. And finally, how much does this fantastic association cost? So if you're a student, it's like $30, and then depends on your salary is how the rate is calculated. So it goes from 75 euros to 176, and you can pay like lifetime membership, so that you can divide it in 4, so it will be $500. So this is how it is now. We are trying to get some discounts and negotiate if we can change this ratio, but for the moment this is not changed, so I will not talk about it. So well, that's all for me, and thank you for your attention, and I hope you join this Society of Wetland Scientists Chapter Europe.
Thank you, Columba. Thank you very much. So I take advantage of this moment also to, of course, stress out that the four sister projects, including Alpha Wetlands, Resources, REWET, and Wet Horizons, we are clustering gladly with the Society of Wetland Scientists, the European chapter. They are, of course, contributing also to this webinar series. So it's really great to have, let's say, this space for collaboration and exchange. So I will now open the floor to the questions. It's once again actually an open space also to like exchange. If you don't have really questions but would rather pitch in your ideas for furthering this collaboration with so the sister projects or like the Society of Wetland Scientists, this is the place to do it. So do not hesitate to address your questions to Columba or like to stress out further ways to to boost, let's say, the collaboration of the, let's say, wetlands founded European projects with the Society of Wetland Scientists. So once again, I will stress it out that you can post your questions or comments in the chat. But if you want, we can also open the microphone for you and you can share your live comments or questions with us. So we have a few minutes for this before we wrap up this session. So do not hesitate to share your considerations with Columba and us. I don't know if the sister projects also I see that there are lots of participants in this webinar. If you want to stress out something about the collaboration that we are having, or you want to raise some points to the attention of the audience, once again, this is the moment to do so. Okay. I think there is actually a question from, first question from Miguel, so we read it out loud. Thank you, Columba. I'm curious as to what are the implications of the Wetland of Distinction Award. Could you explain a bit more?
Yes, so it's a level that for designate a wetland that is in a good state in terms of conservation and biodiversity, social benefits. So it's you have to write a folder with many, well, not many, but describing in detail all the aspects of your wetland that really highlights why it's important to conserve it, to conserve and to get this level of wetland of distinction. So it can be different focus. You can focus in one species or more the social ecological interaction. It's not that everything has to be perfect, no? It can also be restore wetlands, but the idea is to encourage the wetlands that are in a good function to be recognized, no? But that is something that is more known in the US, so it would be good to spread the word of this possibility of getting this label or this recognition in other wetlands around the world. Thank you for your question.
Perfect. Thank you, Columba, for addressing the question. Thank you to Miguel for raising it. I don't think we have other questions in the chat. If someone wants to speak or raise a point, now is the moment to do so. If not, I will go to the wrap up of this first session. I think we're good. So Lena, please move to slide to the next slide. Thank you. So I take this occasion, of course, to advertise the session 2 of this webinar series, which will be held on the 16th of December. Registration are currently open. My colleague Irina will post the registration link for you in the chat, but please do not hesitate to reach through the Sister Project's website and social media channels for updates and more information. Everything will be conveyed there, so please stay tuned. I take advantage of this occasion, of course, to thank all the speakers, the audience, and also my colleagues, Irina and Lena, who gave me technical assistance and walked you through this this very nice first session. So once again, the registration link, it's in the chat, so do not hesitate to register directly through that one. But once again, it will also be available and spread through the Sister Project's so social media and website. Next slide, please. So very briefly, this session will close with a final feedback questionnaire. Once the webinar is over, actually you will get a questionnaire popping up automatically. We will be very happy if you can contribute with your feedback about this first session. It will lead the ground to the following sessions and will help us also fine-tune the webinars for you as an audience. So this, once again, next slide, please, Lena, is to thank you very much for joining this first session. I hope you enjoyed it, and thank you again for all the speakers for sharing their research and insights about wetlands restoration and conservation. So I tell you to see each other directly at session 2. We will be waiting for you for a pre-Christmas webinar series. So thank you again for joining. And I think that if you don't have any comments or last very minute questions, because we're 2 minutes ahead of schedule, which is a great result considering the tight timing that also the speakers had to respect. Now is the moment. If not, I thank you again, and yes, invite you to register to the second session. Thank you. Perfect. I think that now we can close. Thank you again all very much, and see you at session 2. Bye.
Thank
Thank
you. Bye-bye.
you.
Bye.
Bye.
Thank you. Bye.
Thank you.